read-write is 0, then it's a write operation. So I put here all possible addresses that we can have, assuming this is just an example. If we assume this is the content of the memory, this is the content of each word, then, for example, in this address, if we access this memory, the content is 0. Yes, Mohammed Al-Fakhro?
Yes, Doctor, just a small question. Why is the read-write here on the right side and in the schematic you drew it was in the bottom side? The side doesn't matter, or it differs from one memory to another?
No, it doesn't matter. It's just a schematic representation.
Oh, okay.
It doesn't matter. Even when you go to buy the memory, you will have different, for the pin out is different. I mean, it doesn't matter.
Okay.
Doctor, can you talk about the exam, please?
Pardon? Who was talking? Right. General memory operation. Read-write. So this is an example again with if you use the previous memory. So I have 4 bits. So this is 32 by 4. So for example, writing the data word. If I want to write this word 0, 1, 0, 0. Here you need to be careful. I mean, the size of the word is 4 bits. Yeah. Into memory location. If you want this memory location. 0, 0, which is 3. This one, yeah, the one that I put here in red. So this is 0, 1, 2, 3. Memory location 3. If I want to write this word, which means we need to overwrite whatever was there before. So what we need to do is we have to provide the address. This one. When I say we, it's the job of the CPU or the control unit. This is what it does. So it provides the address, the data input, the data that we want to write. So this needs to go to the data bus in, and then read-write needs to be low, and then ME needs to be high. So this means 0 and this means 1, right? We need to enable the memory to be enabled. And then I don't care about the data output because it's not used for this case because it's writing. You don't care about it. Right. Reading. If I want to read the data word, this one. So the memory location is this one, which is 14. Memory location 14. So we need again to provide the address. So the address is very important, is the first thing. Data input, I don't need to provide any data input because I just want to read, so I don't care about this. Read-write needs to be 1 because it's a read operation. This one again needs to be high. And then once we provide this, the memory will output this value. So in the data out, this is data out. It will be 1101, and this is data in. Is this clear? CPU memory connections. So as I said, inside each microcontroller, we have the core or the CPU, same for the microprocessors, and they use memories. Again, the 2 types of the memories that you find in all of them is the program memory and data memory. Some of them, they use only 1 memory and it's shared. Part of it will be for the code, and another part of it will be for the data. So it says, for example, from address 0 to address, I don't know, 1024, it is for, or 1023, it's for the code. Addresses after 1023 are for data. Or they have separate memories, right? One for data, one for, and they, of course, this needs to be connected to the CPU. We have, we talked about the pins that we need, or the inputs and outputs that we need in a memory. We have three types of buses. We have the address bus, which is, the address bus is an output from the CPU, and it's an input to the memory. We have the data bus. The data bus is bidirectional.
Sorry.
The data bus is bidirectional. Input, output. So we have the input bus from memory, and we have the this is input, it goes as an input, and this is output from the memory. And they are connected to the data bus, to this of the CPU. And we have the control bus. The control bus is the one used for the other lines, which is, for example, the memory enable, the read-write, and so on. Some they have other pins, but those are the most important ones: the memory enable and read-write pin. So we have three types of buses to connect the memory to the CPU. So this is how it's connected. I talked about this. This is what I was describing in the previous slide. So data bus, control bus, and right. So this is how the CPU performs the read-write operation. So first, the CPU places the memory location address on the address bus. The CPU places data to be stored on the data bus. This is for write operation, yeah? So I'm describing the write operation. So we need to, the CPU provides the address, then the data to be written, and then it activates the control signal for a write. So read, write is 0. And then this is what the CPU needs to do. Of course, assuming that the memory is enabled, yeah? If not, of course, it needs to enable as well the memory. And then next is, once the memory received the address, received the data, it will determine location for memory storage, and data on the data bus is transferred to the selected memory location. This is performed by the chip, the memory chip. So it takes the address, it takes the data, it goes to that address, and then it overrides whatever is built in that address with the new data. And that's it. The read operation, so the CPU places as well the address on the address bus. It activates the control signal lines for read, so which means the read write is 1. Of course, it needs, I'm assuming that the chip is enabled, yeah? If not, of course, it has to be enabled as well by the CPU. So it needs to put on the control line as well, activate the memory, or enable the memory. And then that's it. This is all what we need for the read operation. So then the memory will take the address, determine location of data being retrieved, and then the memory will place data from the memory location onto the data bus. Yeah, I think it makes sense, and this is how it interacts with the. Yes, Murtaza?
Yes, Doctor, I just have a small question. Is there a specific reason of there being a dash on top of W? Or is just notation? And when
it's a notation, and as a human, you know that W bar means it's active low. This is bar, yeah? Do you know what is W bar? Yeah, if I say read, if it's 1, there is no bar here, right? If I want a read, I put 1. If I want a write, if I put 1 here, which means W bar is 0, right? W, if I want 1 for W, it becomes 0 because I have bar here. It is just a notation to make it easy for the human to, to understand that 1 is for read and 0 is for write. Is this clear?
Yes, clear. Thank you.
Yeah, W bar, this means this is like active low for write. And is active high, it's a normal logic for read. Normal logic for read is the inverse for write. But again, it's a notation. It's just a notation. I can just call this pin A. Doesn't matter, right? It's just a name. So A is when it's 1, it's read. When it's 0, it's write. It's just a name. It's a notation. But for us as a human, it's good. So we can, when we put bar, it means it's active. Right. Read-only memory. So now I'm going to talk about the two types of memories that we can have. You have read-only memory, and of course the program memory and the data memory are RAMs, are not ROMs. But ROMs are used in digital electronics, are used as well in embedded systems for different applications. The ROM holds data that doesn't change. So if you have a ROM in a circuit, this means it has data that doesn't change, which means you cannot write to it. You just read from it. When you design your circuit, you identify what needs to be in the memory first, and then there are special devices that can use to program the memory with the data that you want in the memory, and then that's it. You use it in your circuit. So we cannot write to it. Once it is in the circuit, there is no write operation, which means there is